Awesome. So, folks, once again, I really appreciate it for the time guys are having here. The purpose of this session, as I just mentioned to you, is to walk you guys through a few new features that were introduced since last year and also during the year in 2021, and explore new things that gonna be useful for you to get more skills around machine learning with AWS. So as you guys know, the Amazon SageMaker is a fully managed service that allows developers and data science that to use and build for training, deploy machine learning models. There are a lot of components to SageMaker, whether you are using the managed development environment or to training clusters or doing some hyperparameters tuning or to deploy endpoints. So there are multiple things, and I'm gonna be providing a few things so that you guys can get familiar on all the things. Maybe some of them would be familiar to you, some of them will be not. So I'll be providing this walkthrough because my intention with that is that you guys to have everybody on the same page with the more advanced features and things we're going to be covering during the day today and also over the course of the next 2 weeks within this training. So before we can cut to the chase, in just a moment I will dive deep into some of the key capabilities of SageMaker. But one thing that is worth mentioning is that, of course, everybody knows that machine learning is critical to building modern business, right? So it's a core. Everybody knows that businesses are investing a lot in machine learning. Some of the analysts like IDC predicts AI spend is going to be reaching $100 billion by end of 2022, up to 2.5 times from 2019. So this is a huge investment. And we, of course, as partners from AWS, we need to get ready and understand where our customers are investing and how we can differentiate ourselves, right? One additional thing here is that machine learning projects are moving rapidly from piloting to production. As you guys probably have seen as being individuals that are advanced with machine learning. We can go back to a few years ago. Most of them were kind of experimenting with machine learning, but now they are turning that into this is uh, has become a process that all customers are taking that very seriously and turning this into things that are driving the way their companies are doing business with their customers, right? And of course, we as AWS, we have helped tens of thousands of customers with machine learning. And one trend that we have seen across all customers that establishing a machine learning platform has become the starting point for anyone looking to develop machine learning applications. So this is going to be a differentiator, right? And we need to be prepared for that. And of course, as you guys might be familiar, we have a range of different services. And when it comes to machine learning with AWS, we offer builders with the right tools for the right jobs and providing the choice of tools, right? When it comes to AI machine learning, AWS offers a broad and deep set of services to support cloud infrastructure so that you as a developer or a partner can put machine learning in the hands of every data science and expert practitioner, right? And SageMaker is the middle of our three-tier stack and is intended for anyone who is looking to be training, deploy their own custom machine learning models. That's the one that we're going to be focusing during the session. And I wanted to provide special details around things we have introduced, right? Since we started. The reason why I added this slide is pretty much, of course, so you guys can identify some of the steps in a machine learning journey, where is picking up the right algorithm, train models, label data, collecting prepared data, store features, check for bias. And the point is, machine learning development is a complex and costly process. And sometimes there are a few barriers to adoption at each step of machine learning workflow, right? So this is one of the things we got to have in mind. And also, there are some projects that are lengthy, have lengthy times for training, which leads to higher costs. There are also things around tuning your hyperparameters, which can be a very long cycle and require adjusting thousands of different combinations to find the sweet spot. So these are the things, and also on top of that, to make things more complicated, many of the tools developers take for granted when building traditional softwares, such as debuggers, project management, collaboration, and a few others, they are not integrated, if you will, right? They are kind of disconnected. So the purpose of with AWS, especially SageMaker platform, is to turn this into something accessible for a single point. So if either a developer, whether being a developer or uh, data science or a end user, you have access to a variety or range of different features from the same platform and from the same set of tools, right? So speaking about SageMaker, I wanted to provide with a quick overview. Of course, we have this the main phases when it comes to machine learning. That is the preparation, the building phase, training to, and deployed, right? And as I mentioned previously, uh, SageMaker is a service with a lot of different features and capability we need, right? We typically talk about those capabilities falling into those categories, and actually, those four categories really address the needs that all the builders have when dealing with each stage of a model's life cycle, right? And one important thing here, later in this session, as I mentioned, I'll give you a full feature tour of as many of these features that might be interested to you. So I'm going to focus on things like uh, feature restore, clarify, SageMaker processing. I'll be talking about autopilot as well. I'll be speaking about the integration with Kubernetes, SageMaker pipelines, and most of the things you guys can see here. And also on top of that, during the course of these 2 weeks, you guys are going to have the opportunity to dive deeper into some of the things I won't be speaking during this particular session today. So let me start with the feature engineering and data exploration, right? So one thing that is a reality is that around 80% of the time spent on data preparation, it's when it comes to machine learning, 80% of the time is spent on data preparation, right? That is the first step of building a machine learning model. So it's kind of a time consuming, and it consists of all these a few different steps. And as you guys are familiar with, because you are high skill with machine learning, sometimes these the data preparation steps is kind of tedious and research intensive uh, due to the high nature of the data being kind of dirty, right? So you need to deal with the raw data, and this dirty data or raw data could include missing or uh, uh, erroneous values, some outliers. So you gotta manage and handle different kinds of scenario where you're missing data, where you need to transform your data before starting training your model, and and most of the time the data preparation often needs multiple steps. So one of the things that we have observed is that while most standalone data preparation tools provide data transformation and feature engineering visualization, just a few tools provide built-in model validation. right? And this is one of the things that we wanted to provide out of the box. So this is a typical process when it comes to data preparation, right? So you need to collect the data, prepare the data, transform the data, and also we have a pipeline for the data preparation, right? So once the data is collected, you need to be transformed into something in a usable format. Like you gotta transform your data to write code to complete tasks like converting numbers into floating points, dates into timestamps, or eventually converting category text labels into integers, right? So this is kind of the things that are you gotta be working, and of course there are multiple ways to address this. And of course, as part of this data preparation process, there is questions on do you need to combine columns or do you need to remove outliers? Do they represent the real world? Are my x and correlated with my x's correlated with each other? How what the process look like? You know, what are the things I need to be concerned to have a an important set of data that's going to be used because at the end of the day, this is key. This is instrumental for a successful machine learning project, right? So, and that's where Amazon SageMaker Data Handler comes into play, right? Of course, there are multiple ways to do this. One individual can use Glue or EMR, as we talking about in the first day. Also, we can use Pandas, right? And then, but on top of that, we provided this platform, the SageMaker Data Handler, that is integrated not with all the other services in the platform, like the feature store, SageMaker Pipeline. So the purpose of this overall platform is to provide with a single experience from the developer perspective where the individuals can track all the steps of the machine learning from a single platform, from a single IDE, and have these all the tools that are part of the overall platform to talking to each other, right? Not to be a standalone experience, but working together, right? So, for example, instead of requiring complex queries to collect data from different sources, with this platform, you can pretty much select data from multiple data sources like Athena, Redshift, Lake Formation, S3, and the feature store. This is a it kind of create write queries for to import data from these data sources. And when it comes to transforming your data, the SageMaker Data Handler offers a rich selection of pre-set up data transform. So it's just like kind of accelerators such as things like to convert column types, rename columns, delete columns, things that you're going to be using regular to convert text view column into a numerical column with just a single click. You don't need to write the code. And of course, the SageMaker Data Handler, it provides a source code. You need to tweak a few things and make a few changes, right? And once the data is transformed, the SageMaker Data Handler makes it to clean and explore the data with the data visualization integrated within SageMaker Studio. So these are kind of the things that they're going to be learning. And I like this slide because it pretty much summarize all the steps taken by the SageMaker Data Handler and provide details on what functions Data Handler performs at each step. So pretty much the key takeaway here is that these steps can be iterated on in whole or in part to quickly build a strong set of data transformation code and features to improve the performance and the quality of your machine learning models. So and let me provide you walk you through on some of the things I just spoke, right? So basically, this is a screenshot, and of course, you guys, we're gonna have a session where we're gonna be during the day where when Sergio quick started the first lab, you guys gonna have the opportunity to kind of play with these features, right? So you're gonna be able to select data from different data sources, write queries, import data into various file formats such as CSVs and so on. This is kind of the things we're going to be seeing. Also, you're going to be using the accelerators and the pre-set up uh, pre-configured data transforms, including things like to convert column types, delete columns, and to kind of working with the data preparation and to prepare your data set with the features you exactly need. And also on top of that, with this platform, you are able to detect bias and kind of identify data set imbalance with Sagemaker Clarify. Even during the data preparation step, this is something that is key. I'm going to be providing more details, but this is something uh, that is really a breakthrough, right? It's kind of a watershed because in the past we have different set of platforms, and now we have everything integrated within a single platform. When it comes to data visualization, that can be helpful to understand your data, of course, and with a set of pre-set up visualization templates, including those scattered plots, boxes, and other line plots, and different kind of charts. Uh, with with the data handler, you can kind of create and edit your visualization so you can quickly detect outliers or extreme values, and things where you need to be kind of addressing to improve your data set. And on top of that, you can quickly estimate model accuracy, right? Uh, with this new service that some of you that had the opportunity to work with, you can kind of identify inconsistencies in your data preparation workflow and diagnose issues before your models are deployed into production. And this is really key because you don't need to kind of training, deploy your model until you can identify those inconsistencies, right? So we have the integration between this data handler and also Clarify to identify bias in your model, and then kind of proactively figure out ways to fix some of the gaps you have, right? So this is really key. And on top of that, you can deploy data preparation workflows into production, right? You can easily take coding to production with data handler. Well, what I mean by that is that without manually uh, translating hundreds of lines of code of data preparation, you can pretty much export your data preparation workflow to a notebook or code spread with just a single click, and then easily bring that data preparation workflow into production. And that's kind of the integration that it has with the SageMaker pipeline, which, by the way, we're going to be focusing. We're going to have a dive deep on the next week, on the week two of on the day two of week two. So just so you know. But of course, there are other ways to to ingest data, to prepare data, like using Apache Spark through the EMR, as we spoke about in the first day. You can, of course, use pandas to prepare their data, and this is one additional platform to a range of different services that AWS provides to fit your needs. So it's kind of we provide multiple options, and then you can pick up the ones that makes more sense according to your needs. And moving on to the next topic, I wanted to explore more on the feature store for those of you that are not familiar with that. Well, if you take a look at this slide right here, we all know that features are a critical step, including machine learning, as they can help improve the quality of their predictions made by their machine law model. For example, let's say a fictitious scenario where we have insurance and claims processing model, and we need to take an input entity. So let's say driver profile, driver ratings, vehicle characteristics, which is associated with structured data and many other different things. So we kind of translate that raw data into feature vector, like you guys have seen right there, right? And this is what what we call as the feature engineering, the feature processing. So you guys are familiar with that. But the point is, let's say you're building a machine learning model for an automotive insurance claims processing, as I just mentioned. So you gotta find multiple data sources like vehicle damage images, claims, customer data, tax interaction, telemetry data provided by the cars, sensors installed in the cars. So with that, you have various sources of raw data. Uh, you gotta set up a feature processing logic in most cases. Uh, so let's say we have multiple data science teams, right? That could be working a customer churn model that relies on features derived from vehicle damage images and those tax interaction. What happens at the end of the day? Uh, in a regular world, without using a thing like feature store, you're gonna have a model, right? And you're gonna have different feature pipelines. And what happens is that these create like redundant pipelines, and you gotta have to re-implement some of the features once again. And this is kind of becoming kind of a pasta or macaroni, where you're gonna be using uh, features are gonna be replicated. We are gonna have to repeat the same process, and that's gonna be resulting in a feature pipeline, a spread and no standardizer across different flavors of transformation logic for the same feature implemented within the same business, the same enterprise. And that can become a nightmare for both the government perspective as well as accuracy perspective, because at the end of the day, that would be individuals or teams doing managing and manipulating the data in a different way. But if you kind of have a central repository that centralizes everything and provide this governance, that would make the developers, the data science lives much easier, because the same data generated the features, but they are doing just exactly once. Whenever the features are processed, the feature is committed to a central feature store, which serves as the single source of the truth. Right? That's a kind of we are revamping the way things are doing, and this is one of the things. This remove redundancy. Developers can easily search the centralized store to discover features. Various models can now rely on the central feature store. The feature pipelines run just once, saving time and money, investing in processing features. There are multiple benefits when it comes to the feature store. So this is kind of a summary, right? And speaking about the how it works, I think this slide helps you to visualize how Amazon's feature store works. So once you have a meaningful features from raw data into the feature store, you can ingest data for both streaming and batch applications storing relevant online or offline feature store. So the feature store works only works for both uh, prediction and also uh, for offline processing, right? For real time and batch inference. So this is super helpful. So the online feature store is primarily used for real-time predictions, and when you have batch predictions, you can use the offline feature restore. And the difference is that the left side with the online feature restore, you gotta have a low millisecond latency read, whereas with the offline feature restore, you're gonna have uh, less than 15 minutes read after write consistency. So that's the major one of the major differences, right? And one of this is one of the key capabilities, as I just mentioned. Individuals using the platform, developers, whether a developer or a data science, they can search and discover features using the feature store as a single source of truth for individuals. You can manage features using the feature groups, right? Actually, there is a feature that enables a kind of logical grouping of features called these feature groups, right? So pretty much they consist of features that are computed together, so related by common parameters or using often together for similar applications, right? So this is the kind of things that you can correlate uh, fields and features together. And speaking about the Amazon SageMaker Clarify, this is another important topic, right? Just as a reminder, what is bias in machine learning? So let's think about it for just a second. Most of the time is uh, one of the most common cause for bias, of course, in machine learning is that where the training data is meeting samples for some underrepresented groups or categories. So let's say we are talking about a fraud model, right? And then 99% of your data uh, is not related to a fraud. So you guys are gonna kind of having bias in your model because when a fraud happens, your model is most likely to not be able to to identify that. So you gotta kind of work with false positive, false negatives, true positives, true negatives with that. And at the end of the day, you gotta have a meaningful amount of data to represent each category, right? So, and that's where Amazon SageMaker Clarify comes into the picture because it provides a way to identify this ahead of time. So here are the few challenges with managing bias in machine learning today. So usually it requires piecing together open source packages and write custom code, testing data sets and model for bias across all the steps of the workflow, then manually piecing together a series of screenshots to create a report showing the factors that contribute to a model prediction. So you kind of have to use multiple different platforms. And once the model are in production, data science must regularly checking for introduction of bias from changing real world conditions. So it's kind of a hard problem that is solved by the Amazon SageMaker Clarify. Well, the purpose of this SageMaker Clarify is that it helps you, as I mentioned, is integrated with Data Handler. So it's so easy, straight to the point to identify bias even during the data preparation. You can check your training model for bias, of course, and you can monitor your model for bias. So it not only works with the data preparation, but it covers the the entire life cycle of the machine learning process. We're going to have a lab this Friday where you're going to be providing examples on how to identify bias in your model and how to get them solve it, right? So we're going to be providing more details. And as I just mentioned to you, Clarify works across the entire machine learning workflow to implement this bias detection and explainability. For example, uh, you can look for bias in your initial data set. You can check for bias in your training model as part of SageMaker experiment, and also explain the behavior of your model overall. You can extend the SageMaker model monitor. I'm going to be providing more details for changes in bias and explainability over time in your deployed model. And also you provide explanation for individual inferences made by your deployed model. So it provides a full picture of the entire process and is integrated with different SageMaker features and services, right? So data handler, autopilot, processing, hosting, and SageMaker model monitor. Here's the thing when it comes to perform bias analysis during exploratory data analysis. So, for example, in this case, SageMaker Clarify enables the developers to specify attributes of interest, such as, in that case, location or occupation, and runs a set of algorithms to detect the presence of bias, right? And after all, it provides a kind of report, as you guys are seeing here, a report on the bias that were identified from the sources uh, and several of the steps that you can take to mitigate those risks, if you will. After you train the model, you can check the training models for imbalance, such as more frequent denial of service to one group over another. This is one of the things that can be done with Clarify as well. And this is kind of the things that is important to understand, right? Clarify works across all the entire journey as integrated. We're going to have a dedicated session on Friday so that you can dive deeply and jump into this feature to get up to speed on what it works and to get your hands dirty. Uh, Sagemaker Studio is a really straightforward visual integrated environment we're going to be talking about. Let me move on. And Amazon SageMaker processing, not sure if you guys have worked with that, but this is a kind of a managed solution that provides a way to implement out of the box scripts for pre-processing, post-processing, for model evaluation. Of course, there are multiple ways to address this, but with just a single a few lines of code with Python code, you can implement pre-processing for data preparation, post-processing, and you can integrate with your own container in case you are creating your customized processing script, right? So this is one of the things that you gotta be familiar. This is actually not new. This feature I think was introduced in 2019, if I'm not mistaken. Maybe I might be wrong, but uh, this is important to know, and because as I mentioned, there are several ways to do that, and you guys need to identify which ones is the best fit according to your customer requirements and to the model you gotta be implementing. Flexible model training and tuning at scale, right? This is one important piece to understand. Of course, I won't go through all these. And again, we have a dedicated session to go through the built-in algorithms this Friday, and most of you are going to be familiar with that. But of course, there are a range of different algorithms that are provided out of the box within SageMaker to make developer lives much easier. So there are containers that you can just initialize and then using for a variety of different projects like things with supervised learning, unsupervised learning. Um, you guys can use reinforcement learning. You can use object detection. You can work with CNN, uh, uh, deep learning, without having to import a container, right? So this is something that is provided out of the box, and we're going to be exploring more during Friday. The next one is that with SageMaker, you guys can package your own algorithms that can be trained and deployed in the SageMaker environment. And this is helpful. But the question is, when should I build my own algorithm in container, right? Because you said pretty much it's covered. Well, I'll not say pretty much, but you have uh, a huge amount of built-in algorithms that covers most of the use case with machine learning. That's true, right? But you may not need to create a container to bring your own code to Amazon SageMaker. For example, when you're using frameworks like MXNet or TensorFlow that is covered within the SageMaker, you can simply supply the Python code that implements the algorithm and using the SDK. But sometimes even when there is a direct SDK support for your framework, you may find it more effective to build your own container. For example, if your algorithm is quite complex or you need special additions to the framework, kind of you need to mix and match with some external frameworks or something that you wanted to manage yourself. So that's where bringing your own algorithm and creating your own container comes to pen is going to be useful, right? We're going to have a dedicated session. I'm going to be covering this portion during Friday. And then we're going to have a deep dive, hands on, with multiple challenges. We're going to be introduced to an environment where you need to fix a few things as a kind of challenge for you to understand what the process look like for using SageMaker with bringing your own container algorithm with a PyTorch model. So stay tuned because that's going to be one of the exercises that I'm going to be running myself on Friday. Compute instance for each workload. Why this is so important as well. So, of course, you guys have SageMaker. We have multiple algorithms. We have multiple platforms that support the entire machine learning process. But you gotta understand what kind of compute instance is ideal for each workload, right? So of course there are a kind of compute instances that are only suited for running the notebooks. A few of them can be used for simulation and inference workloads. And when we need more specific training, or you can use general purpose GPU, or we have a range of different compute instances for different types. So, for example, the P3 instances are a great choice for fast distributed machine learning in the cloud because it provides up to 8 NVIDIA Tesla GPUs, 64 scalable vCPUs, Intel Xeon Skylane, 25 gigabytes networking throughput, 16 gigabytes of memory per GPU. So when it comes to training your model, but of course, uh, you gotta find the sweet spot because sometimes using a more sophisticated and more advanced uh, computer instance can result in more cost. So you gotta think about ways to improve your experiences, and one of the ways is kind of using the some of the distributed training libraries. So most of you gotta be familiar with Horvath uh, and TensorFlow. That's a way. But I wanted to introduce you with a few things that are available for free. Eventually, you haven't heard about. But just so you know, before speaking about this library, I wanted to kind of remember about a few things, right? So what are the challenges? So sometimes we have large data sets that take a long time to train, creating a bottleneck. And sometimes we have large models or models with many parameters that can exceed the memory capacity of a single GPU, right? So the problem is twofold. So training large data sets can take a long time and create a bottleneck. For example, let's say we are picking up Roberta uh, for training uh, some of the deep learning models with images that are terabytes of data. That's an issue. And what are the solutions to implement that? Pretty much, it boils down to two things. So we have data parallelism is where when you split your data across multiple GPUs to train more quickly than if a single device were used. And on the right side, you have model parallelism is where when you split the model itself to avoid GPU memory limitations, right? So, but both of these come with their own set of challenges. So, for example, for most of existing data parallelism solutions are open source, meaning they are not optimized for any specific cloud providers, infrastructure and network. Speaking about Horvath, I'm going to be providing just a comparison so that you guys can be familiar. And of course, Amazon SageMaker support all these different flavors, if you will. And also we have the specific libraries provided out of the box with SageMaker that provides with uh, uh, even better performance if you need. Another challenge is when moving to a bigger GPU doesn't necessarily solve all challenges if your model is large, right? Uh, Bigger computing instances are more expensive, as I just mentioned. Uh, and beyond a certain point, even the largest GPU is too small for some models. And then sometimes you need to split the work across different things. So what is the purpose? What is the how to tackle and how to solve this? So uh, with these distributed libraries, pretty much we offer managed model parallelism and data parallelism libraries for distributed training, right? So uh, you gotta have opportunity to reduce training time by up to 25% or more by making it easily to split training data across GPUs. Uh, just so you know, just as one example, there is a benchmark training the CNN convolution neural network on a P3DN with 24 extra large runs 25 faster on SageMaker compared to Horvath. Just so you know, right? And at the same time, it's going to be cheaper. So, what are the use cases for distributed training libraries? So, computer vision, NLP, recommender systems, right? And here are the things, just so you know. When it comes to data parallelism library, right? What happens when working with SageMaker? The process is very simple and straightforward. Pretty much the first step is that developers or the users start by importing the data parallel library into their training script and launching a training job with the data parallelism enabled. It's very simple. It's just a flag. And also this can be used with existing APIs you may have in place like Horvath for TensorFlow or even distributed data parallel for PyTorch. So in case you are working with those open source, that's okay. No problem at all, right? So, and the next step is when SageMaker runs training, it automatically splits your data into fully managed working nodes and synchronizes work across all the GPUs automatically. So you don't need to think about that. And then your model is available in S3, ready to deploy. This is one additional point. And the other side, we have model parallelism, right? We have a library that supports that. So again, users start by importing the model parallel library into their training script. Just need to enable a flag. And when the SageMaker runs training, it automatically analyzes the profile of your model, kind of partitions it and send those pieces of the model to different machines, if you will. And then there is a pipeline that micro batch of your data to keep all pieces of the model running in parallel without one section having to wait for another. And then again, your training model is available within in S3, ready for deployment for inferences. And here is for just for your reference, I'm going to be keeping that to you. There is a benchmark comparing like a this process for object detection with deep learning using a region-based convolution neural network, right? Uh, Using different set of machines, and you guys can see the performance comparing using SageMaker versus the TensorFlow with Horvath, just so you know. One additional piece here, and of course, most of you got to be familiar, this is not new, but we wanted to highlight this during our training, is that we have tuning model hyperparameters. But the point is, often there are a few questions, right? Often what separates good models from great ones is the choice of these hyperparameters. So things like how many layers should I use, or what is the best learning rate? Should I use a dropout? How much? And the list goes on and on, right? So usually what happens is that this takes a lot of time. So the bottom line is that we gotta be prepared to deal with that by taking advantage of uh, services that are provided out of the box with SageMaker. Of course, hyperparameter tuning is one of them that is integrated with Bayesian optimization, right, for providing the best model. But now they also integrate with SageMaker experience for a smooth end-to-end experience to visualize the results and to move quickly to production your model. And speaking about ways to improve experience, I just wanted to talk about the SageMaker Autopilot. Also, this is not new, but it's worth mentioning that usually we find customers ask over and over how to help speed up the process of getting classifications and regression models built on the structured data. And as you guys know, the vast majority of machine learning use cases fall into this bucket. And there are tried to through some approach to feature engineering, algorithm selection using hyperparameters tuning, and that sometimes becomes a awkward process. If you awkward process for them to identify the right model, and that's where SageMaker Autopilot comes into play, right? You pretty much need to import SageMaker to your data and tell what you are trying to predict. So, and then the autopilot analyze the data, figure out what kind of problem is being solved, and what feature engineering is needed to kind of address the problem, right? And then in the end, you get a set of models, including the best one, and you also get model the kind of model evaluation method with short, and you get a recommended Jupyter, you get a commented Jupyter notebook to reproduce the work, and then you can kind of steal code from that as a starting point for building your production model. And just speaking about the uh, the project that the capstone project that we need to deliver, that can be super helpful for you to kind of you know using this as a starting point to identify what model and what algorithms you're going to be using to address the project, right? And that can be that turns out to be super useful. And what it provides at the end of the day integrates things like vision optimization for hyperparameter tuning, regression, it support regression, binary and multi-class. It support a few other algorithms like XGBoost, linear learner, and that's going to be that turns out to be super helpful with tabular data, right? And this is kind of where the autopilot looks like. We're gonna have the opportunity to play a bit with that. And speaking about experiment tracking capabilities, one last bit that I'll be highlighting in the beauty phase is the experiment management. So uh, SageMaker now, of course, this is not new, but I have we wanted to ensure you as a developer are taking advantage of all the things are available, right? So give you the ability to trace back history of your experiment. You can have a kind of history of what is happening with results, metrics, leading to the latest model. Uh, you get faster experimentation. Uh, you can kind of uh, automatically manage all the experiments performed by a developer. That's an important piece, right? So this is very very important to kind of working. And here is what the interface looks like. Again, that's going to be available within the uh, SageMaker Studio. You guys can play with that, and we can track thousands of training experiments to understand the accuracy of your model. And then you're going to be seeing charts to provide a more uh, insights on what should be done and to keep track of your training jobs. This is super helpful because most of the time you spend time to tune your training process, and then you can keep tracking of what is going on and to determine which one is going to be the sweet spot for you to take into production. And speaking about the developer phase, uh, sometimes debugging your process is kind of uh, difficult process, right? So have lack of integrated tools resulting in uh, separating and spread different platform where developers need to pick up information from different platform and merge everything together to kind of provide something meaningful to identify where the bottlenecks are or issues with the model are, right? And pretty much what happens is that this helps you visualize how debugger works, giving you insights into the training process and taking action through the detailed report, highlighting those bottlenecks, and to help you, speeding up your training process. So, and again, this is integrated within your IDE, right? So you can monitor and profile system resources utilization. You can visualize system resources utilization for GPU, CPU, network, and so on. And this is kind of useful for, especially for developers that are working on training the model and working with their Python code. And speaking about, I know we are running, we still have only 7 minutes. But speaking about the SageMaker uh, pipeline, this was a new feature that was introduced at re:Invent last year. And with pipelines, data science and machine learning engineers can codify their workflows into repeatable, trackable pipelines. So this is the process, right? So when it comes to machine learning, pipelines, DevOps, one can see that machine learning comprises of multiple steps, right? Some of which takes place in sequence, other in parallel. Uh, when it comes to traditional software development, we have the concept, of course, of CI/CD pipelines that are used to automate the deployment of workflows and keep them updated, right? So pretty much this pipeline reduce errors and provide feedback loops to enable better iterations with all the teams supporting the process. When it comes to machine learning CI/CD, what happens is that it's kind of super hard to set up and configure and manage the entire pipeline. And this is become because to do this, you need to create standardized code recipes for data preparation, model training, model deployment, and then at the end of the day, kind of link each piece together or kind of stitch them together into a workflow so they execute as an automated sequence of steps. So and then you need to kind of package code recipes, then define the order that they need to execute, keeping track of code data and model parameter dependence. So this is kind of challenging, right? And so that again, that's where Amazon SageMaker Pipeline comes into the picture. It's a Python SDK for quickly and easily building machine learning workflows. And again, just mentioned we are going to have a dive deep session, a 1 hour session, just to explore all the options with the pipeline, and then an extensive and profound workshop to explore how to do that and how to kick off a pipeline with SageMaker. Here is the here is a of course a overview on the process itself. But more than anything, I just wanted to give you few examples from the real world on why SageMaker pipelines could be helpful, right? So, what are the typical use cases where one individual or a company will be needing to retrain your model or redeploy your model? So, think about so let's say we are talking about customer churn prediction. So usually, most of the time, we need to optimize models with new data feeds being collected from products and systems while keeping everything else uh, at the same time, right? Up to date. When it comes to personal recommendations, so we need to provide better recommendations as new products and purchasing experiences require continual retraining of your model. So that's a few examples where SageMaker pipelines can be really helpful to streamline the process of retrain your model or uh, you know redeploy your model, if you will, and stream by using a standardized process. And so here is how it works. You get input data, process data, train your model, need to validate your model. Uh, just so you know, the best way to think about these pipelines is that they are a series of steps, as we are seeing in this slide deck. And remember, a pipeline can be initiated through several ways. They can be executed manually by data scientists, either using the Python SDK or the CLI, or even the SageMaker Studio. They can also be triggered by CloudWatch events, such as when a new data comes into an S3 bucket. And lastly, they can also be initiated when codes get checked in your GitHub repository, for example. And let me show you what all of this looks like when the pipeline is defined. Here is a screenshot that pretty much represent all the steps. So with just a few lines of code, model builders can kind of integrate all these modules and these steps for the data preparation, model tuning, and evaluation to define a workflow graph, having well-defined and ordered up execution and data dependence between steps. So that's the purpose of this. And here is a visual representation of this pipeline. So just so you guys understand what the process look like. And again, we are gonna be providing more detail, but the key takeaway is that you can control everything and you can provide a smoothly experience for DevOps taking care of your machine learning models. And speaking about optimization, training, and inference costs, you guys gotta be familiar with that, of course, with spot training, but you gotta remember that uh, you can take advantage of spot instances uh, for SageMaker, of course, because they are ideal for training workloads with flexibility where there's no time sensitive. Work with single instance distributed and even automatically model tuning. You can take advantage and you can reach up to 90% lower compute costs with that. And remember, usually inference is the process that consumes most of the prediction drive complexity and cost in production. So 90% comes from uh, prediction, right? And just a reminder, not sure if you guys have the opportunity to play with that, but the purpose of this SageMaker Neo is kind of train your model once and deploy anywhere, right? So that's the purpose of that. And it provides some optimization for targeted platform. So, for example, you start with a machine learning model built using whatever TensorFlow, PyTorch, XGBoost, and train with SageMaker. Then after that, you choose your target hardware platform like Intel or NVIDIA or ARM, and with just a single click, using the SageMaker Neo, we then compile a training model into an executable, and then the compiler uses a like kind of a neural network to discover and apply all of the specific performance optimizations to deploy that for the target hardware. That can be super helpful uh, to make predictions, especially when it comes to compute at the edge, right? So this is super helpful, just so you know. Elastic inference, for those of you who are not familiar, what happens is that in most deep learning applications, making predictions using a training model can drive as much as 90% of the computing cost of the application due to two factors. The first one is that standalone GPUs instances are designed uh, for model training and are typically oversighted for inference. And the point is, while training jobs batch process hundreds of data samples in parallel, most inference happens on a single input in real time that consumes only a small amount of that GPU compute. And even at the peak load, a GPU compute capacity may not be fully utilized. What is at the end of the day, it's wasteful and costly. And also the second point is that different models need different amount of GPU, CPU, and memory resources, right? So by selecting a GPU instance type, uh, sometimes it's big enough to meet the requirements of the most demanding, but sometimes it's not. Uh, by using this elastic infinity, you can just use a specific amount and a percentage of a GPU, and you can take advantage of. You don't need to be run with overcapacity. So that's super helpful for you when it comes to inference cost, because it can reduce the deep learning inference cost up to 75%, and that's a huge achievement when it comes to cost. We're gonna have a by the way, speaking of cost optimization, we're gonna have a session on the SageMaker well architected, where we're gonna be walking you guys through the 5 key pillars of the well architected framework, but focus on machine learning. We are going to be discussing things like cost optimization, security, management, and so on. That's going to be super helpful because when it comes to machine learning, it's not about only the source code developing. It's the entire process that really matters, and then deliver a concise and platform for your customer. And speaking again, speaking about the cost optimization, not sure if you guys are familiar with that, but we have the multi-model endpoints that provides a meaningful savings for large-scale deployments, right? So you can see that as one of our latest response to the challenge of deployment cost. So let's pick up this example. So let's say I have customers that are seeing uh, in this example, let's say we have a customer that has 10 models to deploy, And by default, this means that those 10, we have 10 separate endpoints, which means we have a dedicated compute for running that. It's still very powerful with a one click deployment, but the point is, these sometimes turns out to not be optimized for the sake of cost, right? But with this multi-model endpoint, of course, we're going to have a dedicated session to explore this on the second week. You have the option to consolidate all these 10 models behind a single endpoint by bringing them by bringing the monthly cost from a few thousand down to a few hundred. So here is the comparison, just so you know, right? And this is the way individuals can pretty much publish that to just a single multi-model. And again, we are going to have a dedicated, we are going to be covering that during our DevOps and implementation session. But it boils down that this multi-model gives you the flexible option to reduce inference costs significantly for certain types of workloads, right? So pretty much you need to design a place in S3 to store your model artifacts as you are doing similarly with a regular process, right? You need to indicate where your model is going to be using, and you ended up with frequently used models having the same performance as they were hosted with a dedicated endpoint. So that's what the process look like. We're gonna have exercise on this in case you haven't ever worked with that. And before we can wrap up, I just wanted to provide with a briefly explanation on monitoring models in production. So the question is, what happens after you get into production? How good are the predictions from your model, or how do you know whether the distribution is consistent or not with the historical predictions? And as you guys are familiar with, the model is going to be constantly changing, right? When they are in production, there are new features coming to your model. Data distribution is changing frequently. Uh, and think about, for example, a fraud model. It is done when you first ship into production. And what is your plan to make it better over time? Well, of course, there will be new customers coming in, new types of frauds showing up in the market, and how you can improve accuracy and better inference for your model. So that's where Amazon Sagemaker model monitor comes into play. So it helps you figure out how well is your model is doing, and you can establish like a kind of baseline. So you train your data, uh, you have your training job, you deploy your model to production, you have your applications consuming that, and then all of your requests and predictions are stored within an S3 bucket, and then that creates like a baseline processing with statistics and constraints that can be used, and then you can compare against the ground truth. And that's going to be providing insights if your model is whether is biasing or not, or as you can see here, you guys got the opportunity to see find with this platform uh, charts with a few statistics to determine things that needs to be done and changing over time. For example, you gotta see some features drift when the model is running into production, which indicate there is a need to retrain your model, and then you can kick off uh, maybe a SageMaker pipeline. So you have the opportunity, including to even to use this SageMaker model and kick off a SageMaker pipeline to retrain your model, so you can automate the entire journey, right? So just keeping this in mind. And just before we wrap up, we just wanted to provide, we have a dedicated session on the integration between SageMaker with Kubernetes by using Kubeflow pipelines and the SageMaker operators for Kubernetes. We're going to have a full lab dedicated to this so that you guys can get your hands dirty. Uh, but that's another way to leverage Kubernetes layer for DevOps team to implement the machine learning DevOps process, and then taking advantage of resource utilization, better collaboration and sharing between the teams, and you can take advantage of this to automate your machine learning DevOps process. And not sure if you guys are familiar with that, but sometimes there are many machine learning applications that require human intervention to review low confidence predictions to ensure the results are correct. So there are opportunities where you need to have humans, and sometimes you need to build your own platform. But now you don't need to do that anymore. This is not kind of new, but I'm just sharing because some of you are not familiar with that. But the process is very simple and very straightforward. Sometimes your client application sends input data, then your, maybe your machine learning model with either SageMaker or using an AI service needs some has some low confidence predictions that needs to be sent for human review to improve accuracy, right? And we have an automated process to do that, and those processes are stored within S3 to be used for to improve the model accuracy, if you will. And we have this automated, and this is what it calls the Amazon Augmented AI, right? You can take advantage and leverage this platform for other services like recognition, text track, which, by the way, we're going to be covering in the second week as well. So just stay tuned. I know there are hundreds of features I spoke about. I'm speaking more over than 1 hour, but this is only to give you a taste on the things you should be aware of that. And before wrapping up the session, I just wanted to provide uh, an overview on the SageMaker's Jumpstart, right? Uh, you can see that it kind of accelerators, which include solutions uh, pre-configured for with all the necessary AWS service to launch a solution in production. So you're gonna find uh, the solutions architecture, the source code, cloud formation, all the things required to, for example, so let's say you wanted to deploy a credit risk prediction model into production. So you don't need to start from scratch. You can just pick up one of these accelerators and then start your process, or maybe using some of these accelerators uh, to identify a few best practices when you are implementing your own process, right? So this is it turns to be super useful, especially if you are uh, beginning or if you are kind of developing new practices, having the opportunity to have access to these solutions development. If you guys are probably familiar with the marketplace and the solutions available we have within the AWS that are things to speed up the process for individuals to get up to speed with a specific service. Provide all the assets, and then you can do something with Jumpstart. So this is only for you to be stay tuned. Of course, there are multiple different things, and that can be super helpful as well when you are kind of starting thinking about your capstone project. And that's it for today. Hopefully, you guys have enjoyed, and see you in the next session. Bye.